and Command F1 on a MacBook with a touch bar. Okay. Yeah, sure, thanks. All right, let's see. Displays. Okay. I think that should do it. Yeah, there we go. Great. Okay, awesome. Okay, can you guys, this good? All right. Awesome. Well, thanks for having me, Eat Denver. And my name is Nick. And I'll be presenting a presentation on modular blockchains, and particularly where we're headed with them, and also, some challenges that I think we're facing, and also some things we're doing horribly wrong currently, and how, the modular blockchain system will affect Layer 2 particularly, and kind of your conception of Layer 2. So in our current kind of state of blockchains, we have a lot of monolithic blockchains. So I don't know, like raise of hand in the room, how many of you heard of this modular blockchain idea and also monolithic blockchains? Yes? Okay, kind of. All right. So essentially, there's a movement in the blockchain space right now, particularly with Ethereum as well, to move us closer to a reality of what we call modular blockchains. But before you can understand that, you have to understand what we call monolithic layer 1 blockchains. So monolithic layer 1 blockchain bundles data availability, settlement, and execution together. And because it tightly bundles these things, you can't specialize, and thus it's not scalable. And so in the monolithic model that we currently see now with chains, things like, Ethereum layer 1 currently as it stands is monolithic, but it's moving towards a different reality. But many other layer 1s are essentially in the monolithic model. And as the previous presenter was bringing up, this is constraining a lot of factors, particularly on bandwidth. So modular blockchains, they separate execution from consensus and data availability. And when you do this, each layer can specialize and be more scalable. And so it's the specialization that you get from breaking up these pieces that allows you to produce far more scale that is secure and verifiable and doesn't affect decentralization. So this is particularly the key for how we head into Ethereum 2.0 and also other data availability layers that are going to come online. And the particular direction is a modular one, where you can expect an extremely high data availability throughput through things like sharding. And we expect even maybe as soon as next year that we'll be able to have tools and the ability to leverage this kind of data. And so this brings me to my next point, which is particularly key and something that I think a lot of people should focus on. And that is that most layer 2s, as you conceive them right now, have a huge problem. And it's right in front of you. And it sort of is something that I think people don't realize when you're talking about layer 2. And it's one particular thing. And you can see it right on the screen, which is that there's a huge fixation on layer 2s to optimize for bandwidth. And so this fixation is very, very heavy. There's a lot of teams that are focusing on trying to get the literal byte size down of transactions with layer 2s on Ethereum. But this is really dumb. So this is not a good idea, and this is a huge waste of engineering resources for the community. And particularly, it is really dumb because bandwidth is a monolithic issue, not a modular issue. And so the constraining bottleneck and the modular paradigm is particularly not bandwidth. And if you focus all of your engineering efforts on producing transactions that are 10 bytes or like 4 bytes, then you're basically building a system that A, we don't need, and B, is particularly not useful, and is also just a waste of engineering resource. In the modular blockchain setting, it's not a problem, again, because the layers are broken up. So a modular blockchain can specialize in things like high data availability. And when you can do that, it opens up the amount of data you have such that that is absolutely not going to be your constraining factor for a very, very long time, at least probably for the next 2 to 3 years at best. So the bigger problem in the space is that not only are we fixating layer 2s, particularly some of the current high-profile layer 2s, fixating on things like compression where they shouldn't be, but we're thinking about modular blockchains and layer 2s completely wrong. It's complete nonsense in the sense of how this is. And it's almost passé in many senses given what will happen and what is about to happen. Layer 2s as a concept only exist for monolithic blockchains. They do not exist for modular blockchains. There's no concept of a layer 2 in a modular blockchain. And this is something that will go out of date very, very quickly as we step into a modular blockchain setting. And modular blockchains will eviscerate the monolithic models hands down because they can separate these things and retain decentralization and security. So we have a massive incorrect focus in the layer 2 space. It's kind of interesting, to say the least. But you see a considerable amount of fixation on bandwidth when layer 2s don't and shouldn't be fixated on this thing. And also, they're just optimizing for the wrong things in general. So they're optimizing for other things as well that don't make a lot of sense to optimize for particularly. And the real bottlenecks are something else. And something that highlights this very clearly is a conversation from Peter, who's the head of the Go Ethereum team. And he was talking with Avalanche on Twitter. And Avalanche, because this is an Ethereum conference, we can riff a little bit. But Avalanche, problematic to say the least, was essentially saying, well, if we can just switch out the consensus algorithm, we can produce enormous amounts of scale. And Peter was like, no, you can't, because consensus is not a bottlenecking factor. It's actually something else, which is the EVM and state growth, and particularly the entire processing model of the Ethereum system. And so this is a very clear and known thing. We are tremendously bottlenecked by these processing systems. And if you just open up the bandwidth even slightly on EVM-based systems, and it doesn't matter whether it's a rollup or a layer 1, you're going to be heavily, heavily constrained by these processing factors. And so the solution to these constraints is to get your mind away from layer 2s and into something else, which is called modular execution layers. Modular execution layers are different from layer 2s in the sense that they are a verifiable execution system, which can be its own layer 1, layer 2, layer 3, sidechain, state channel, etc. The key thing here is verifiable, and it's what makes it different from just another layer 1 or any particular system. A modular execution layer encompasses the idea of a layer 2, but it's a little more than that. It's a verifiable execution system, and verifiable meaning fraud provable, and also focused on something that I think as a system isn't targeted towards a layer 2 for a monolithic blockchain, but is actually optimized, and this is the key thing, for modular blockchains. And so you can forget about the concept of layer 2s and think about verifiable execution systems in essentially the modular execution layer idea. And so this brings me to the shameless plug of the presentation, which is my project called Fuel. And Fuel is planning for this particular modular future. And Fuel is the fastest modular execution layer that exists ever in the world, at least right now. And what does Fuel bring to the table for modular blockchains. It brings maximum security and the highest flexible throughput. And the focus on flexible, meaning general purpose Turing complete smart contracts in the highest throughput setting. So this is really taking advantage of the modular blockchain paradigm and how data will not be the bottleneck. And this is a particular focus for the project in general. And how we achieve the throughput is by de-bottlenecking the existing massive processing bottlenecks that we have by using a different paradigm on the execution layer. And so this is focused on particularly parallel transaction execution, which is something we see heavily with the Solana design. But secondarily, it's also a superior virtual machine. And so to talk to the parallel execution point, parallel execution is a tremendous scaling factor. It allows you to open up more cores and more threads, which means more ops and more compute, which means you have a wider consensus zone over the same data that everyone else will have. So this gives you huge amounts of processing potential that you're not going to get on a single constrained thread or system. And currently, the EVM as it's currently designed is effectively single-threaded. It's effectively only leveraging one thread. So chains that can use more threads and use them more effectively will they'll give you so much more compute and so much more throughput, you won't ever want to use that system again, and it will be highly antiquated. So this is the first thing. The second thing is the FuelVM. And in this, we focused heavily on all of the design shortcomings that the EVM has, particularly around how it handles compute, its bit architecture, the way that it handles calls, the way that it handles memory, the way that it handles almost everything in a way that can be redesigned for a better execution layer and one that has a much wider throughput that it's going to be handling for its node. And the last thing is a superior developer experience. And this is what we get with Sway and Forc. And basically, to sum that up, we've spent a tremendous amount of time learning from all of the mistakes and the shortcomings of architectures that we've seen with the Solidity ecosystem, and we built upon that. But we built upon that also knowing that Rust is a thing, and Rust is a beautiful thing, and that we can learn a lot from that ecosystem as well, and other ecosystems in the space. If you want to see more about Sway and Forc, you can look at Emily Herbert's talk at 120 on the Wave stage, and she'll be kind of going through Sway in more depth, and as well doing some comparisons between Solidity and Sway. And lastly, to bring us to this future, and also to bring us the highly sophisticated machine that we have, and also the throughput potential, I think it's good to highlight that we have more than 1 or 2 engineers on the team. So, a thank you to the 28 contributors and engineers who are on the fuel engineering side that are kind of bringing this to light in every way possible. And if you want to follow us and what we do with these high throughput systems, particularly that will run on things like Ethereum 2.0, you can follow Fuel Labs. You can also follow the language and tooling side as well, which is Swaylang. And you can check out Fuel Network and our GitHub. And I'd highly encourage you to read our specifications because they are thorough, they're very clear, and there should be no edge cases. So essentially, you should read the specs. And we're also hiring. So that's my presentation. Hope that makes sense. Thank you.
Awesome, thank you. We do have about 5 minutes if anyone has any questions. Let me bring you the mic.